Welcome back. I received emails about a flawed published paper on wildfires in the Sierra Nevada that was being overhyped by the media. Having spent 30 years doing ecological research in the Sierra Nevada, I was appalled by Gutierrez's paper blaming summer temperatures for an increase in wildfires and rashly predicting a 59% increase in burnt areas by 2040. So I refer to this paper as corrupted science because in order to blame a variable like average summer temperature, it requires controlling for and accounting for the other known factors that could be causing increased fires. But the media is eager for clickbait news, and blaming climate change attracts the anxious public that are steeped in climate crisis fears. Wildfires provide the perfect propaganda optics as the so-called proof that CO2 warming has the world on fire. So the New York Times, which long ago abandoned good investigative climate journalism, quickly highlighted Gutierrez's paper as adding to the body of work that climate change is increasing wildfire risk. Lesser news outlets and university media, also lacking journalists knowledgeable in the science, quickly echoed the New York Times. And not to be outdone by the Times, CNN fearmongered that the burnt area in the Sierra Nevada will increase by up to 92% by 2040. CNN created that scary number by adding the 59% to the plus or minus 33% uncertainty factor, but without ever noting that according to Gutierrez's uncertainty, it was equally possible that there would only be a 26% increase. Bad scientific papers use bad average statistics, and Gutierrez's paper on wildfires is guilty of using a misleading average statistic. An average statistic is only meaningful if it measures the variations within the exact same phenomenon. But if you average different phenomenon, like apples and oranges, you get useless averages like meaningless imaginary orpals. The significance of an average can also be grossly misrepresented as seen in the graph of average female heights around the world. By only displaying the difference in the average heights on the y-axis, Latvian women who average just 4 inches taller appear to be giants, while women in India all appear to be Lilliputians. An accurate representation of the women's differences requires the y-axis encompass a full 5 feet 6 inches of height to put any differences into the proper context. Now suppose you wanted to scientifically determine the effect of diets in variously rich fruits and vegetables and how it affects women's average height. Averaging all heights of all women from birth to maturity for each country would provide a worthless average. The category height doesn't mean you are measuring the same dynamics. Height needs to be separated into mature heights and still actively growing heights. Including shorter heights before maturity corrupts the usefulness of the resulting averages. For example, in Latvia, 0 to 14-year-olds comprise just 15% of the population, whereas in India, 0 to 14-year-olds comprise up to 31% of India's population. That higher proportion of still growing girls would bias India's average height much lower. And likewise, averaging maximum and minimum temperatures creates a meaningless number. The maximum and minimum temperatures are driven by different dynamics and have very different effects on wildfires. Now here is why Gutierrez's analysis using the average summer temperature was bad science. In 2014, Rapacciulo published the difference between California's temperatures for each region, comparing the 1900 to 1939 40-year average to the 1970 to 2009 average. Surprisingly, the maximum temperatures for 2/3 of California has significantly cooled. Of critical importance to fire managers, it's maximum temperatures that dry out the ground fuels and raise the risk of wildfires. In contrast, the average minimum temperatures have warmed across 99% of California. This stark difference is due to the different dynamics affecting the two measurements. Maximums measure the extent of daytime heating versus minimums that measure the extent of nighttime cooling. Fire experts do not use minimum temperatures when issuing red flag warnings because even if there's an increase in the minimum temperature, the temperatures may still be below the dew point, which causes water vapor to condense as dew and moisten the ground fuels. This dynamic is firmly etched in my mind from doing research in the Sierra Nevada meadows for 25 years. I was in the field at sunrise, and my pants would be soaking wet during the time of minimum temperatures, and only dried out as temperatures heated towards the maximum. But by averaging the maximum and the minimum temperatures together, it falsely appears that all of California is warming. By using that Orpo-like average temperature, Gutierrez argued that climate warming was drying out the fire fuels and raising fire risk. Even though the average was driven by minimum temperatures, they were likely moistening the ground of ground fuels each morning. Now, other scientists have published on the different temperature dynamics of maximum and minimum temperatures. Thomas Carl, past director of NOAA's Center for Environmental Information, published a paper in 1988 showing how maximum and minimum temperatures react very differently to growing populations. Relative to weather stations located in rural areas with populations below 2,000 people, stations in regions of growing populations steadily increased their average annual temperature up to 2.5 degrees Celsius as populations grew to 10 million people. However, the maximum temperatures decreased as populations grew, while minimum temperatures dramatically increased to 5.1 degrees Celsius. Averaging hides these impactful contrasting dynamics. This is just one reason why, when evaluating any changes in California, the effect of its dramatically rising population must be considered. Now, California state climatologist James Goodrich also recognized the population effects and measured temperatures in counties with over 1 million people, with counties below 100,000, and counties in between. Highly populated counties showed a warming trend similar to what's expected from CO2 warming theories. But more rural counties, with populations less than 100,000 people, exhibited no significant warming trend. Instead, temperatures oscillated, as would be expected from the effects of El Niños in the Pacific Decadal Oscillation. Now, despite weather stations near the ignition sites of major California fires that showed cooling maximum temperature trends since 1930s, Gutierrez argued the average warming trend was increasing fire risk by drying fuels and making them more flammable and prone to ignition. Gutierrez simply failed to do her homework. Maximum temperatures from Ukiah, near the ignition site of California's third largest wildfire, the Mendocino Complex Fire, have been cooling since the 1920s. Still, she argued, when a rancher's spike struck a rock, causing a spark that ignited the surrounding grasses, the grasses had been readily ignited due to the average warming trend. She also seems ignorant of the fact that all fire experts classify dead grasses as 1-hour lag fuels, meaning grasses become highly flammable in just 1 hour on a typical warm, dry summer California day. Any climate trend, warming or cooling, is irrelevant. In the Sierra Nevada, Yosemite shows a similar maximum temperature cooling trend. California's 7th largest fire, the Rim Fire, was ignited by an escaped campfire near Yosemite. Nor is there any support for using average summer temperatures in the criteria for red flag warnings issued by the National Weather Service. The primary criteria are: 1, relative humidity of 15% or lower, and winds gusting to 25 miles per hour. And 2, widely scattered thunder showers. The contributing factors to those primary criteria are higher than normal maximum temperatures, thunderstorms generating lightning that naturally ignites fires, and cold fronts that typically promote thunderstorms and high winds. Low humidity is a function of drought, usually associated with La Niñas. Droughts also cause low fuel moisture, as well as minimizing available moisture to condense into dew during the nighttime that would help suppress fire activity. And finally, they look at the energy release component, which refers to the amount of flammable fuels in the region that typically accumulate due to fire suppression. Low humidity is the primary risk factor, which is why the western USA experiences more fires than the east, simply because the west is naturally drier. During the winter, most of the west and the east experience high relative humidity, represented by the dark green. The cold air is holding as much water vapor as possible, so the atmosphere generates no drying effect. As the summer approaches, temperatures warm across the country, so the air can hold much more water. But the transport of water from the ocean to the land differs across the country. The Atlantic pressure system pumps almost enough moisture into the eastern USA to maximize the amount of moisture the warmer air can hold, maintaining a fairly high level of relative humidity and no drying effect. But the Pacific pressure system blocks most transport of moisture, so the region's warming air now receives much less moisture than it can hold, reducing relative humidity and exerting a strong drying effect, and this is illustrated by the brown and yellow colors. The lower the relative humidity, the higher the fire risk. Now we can see this dynamic at local weather stations. In the west at Yosemite National Park, as summer temperatures rise, the amount of moisture reaching Yosemite drops, creating the summer drought and the dry fire weather. In the east at Shenandoah National Park, the summer temperatures similarly rise. But the amount of moisture also rises, creating higher relative humidity and less of a drying effect, and thus reduces fire risk in the east. Now, the transport of moisture to the western USA is modulated strongly by El Niño and La Niña cycles in the Pacific Decadal Oscillation. Between 1980 and 1999, the Pacific Decadal Oscillation was mostly in the positive phase, promoting more El Niños in a warmer, wetter California. After 1999, the Pacific Decadal Oscillation switched into the negative phase, promoting more La Niñas and a stronger blocking high pressure system, causing drier conditions that are more conducive to bigger fires. But Gutierrez did not account for this natural effect. Gutierrez's results in Table 2 provide the crux of her argument. Average summer temperatures in the Sierra Nevada are modeled and based on rising CO2. The model predicts temperatures will steadily rise every decade. I've added a few Fahrenheit temperatures in blue for those who are more familiar with that scale. Accordingly, her model suggested the number of fires will increase in lockstep with model temperatures. But in reality, the number of observed fires has varied, decreasing in the 1990s, rising in the 2000s, and again decreasing from 2011 to 2020. Similarly, modeled results for the extent of burnt area rises in lockstep with modeled temperatures. But in reality, there was no change during the 1980s and 1990s. Then there was a large jump in burnt area from 2000 to 2020. And that increase is due to the drying effect that one would expect from the switch to the negative Pacific Decadal Oscillation. There are many factors, other than summer temperature, that affect the number of fires and the extent of burnt area. Valid science requires those factors must be accounted for and removed before examining any correlation with summer temperatures. Not doing so corrupts the scientific method. However, it does allow fitting modeled results to a climate change narrative. Now, good science demands a researcher must also account for changes in human-caused ignitions before correlating summer temperatures with the increased ignitions. But again, Gutierrez failed to do so. Now, lightning causes the majority of fires at high elevations in the Sierra Nevada. Despite temperatures between 20,000 and 50,000 degrees Celsius, lightning rarely ignites struck trees, even though it can split the tree trunks, and lightning scars are often seen on living trees in the Sierra Nevada. Lightning typically starts a fire by igniting dry ground fuels at the bottom of the tree as lightning passes to the ground. Now, studies such as Balch 2017 show that during the peak lightning season, from June to September, human ignitions still account for a greater proportion of wildfire ignitions. The 600 to 800 degree heat from a single match also provides enough heat to ignite fine fuels, even when fine fuels are only partially dried. Balch's data also contradicts Gutierrez's narrative that warm summers are required for more ignitions. The greatest number of fires are ignited by humans during the cooler months. In the Sierra Nevada, such as around Lake Tahoe, March temperatures are 7 degrees Celsius cooler than Gutierrez's average summer temperature. Furthermore, there's no apparent climate change trend in natural lightning strikes. And this is seen in the medium blue data series here. Now, increased human ignitions are another impact of California's growing population. As people increasingly moved into the wildlands, the electrical grid follows, and accidental sparking increases. The deadliest California fire, the Camp Fire, and the second largest 2021 Dixie Fire were both ignited by an electrical spark. More people promotes more camping in the beautiful Sierra Nevada, but results in more escape campfires. California's seventh biggest fire, the Rim Fire, was ignited by an escape campfire. And humanity always has a small percentage of bad people, so a growing population generates more bad people. Gary Maynard, a professor, was just arrested for lighting 4 fires, adding to the Dixie Fire. Fire officials do estimate that 20% of all California fires are lit by arsons. Now, Gutierrez also failed to account for other purposefully human-ignited fires and how they have contributed to the changes in the extent of burnt areas. To reverse the problems caused by fire suppression, Sequoia National Park in Yosemite began igniting prescribed burns by 1970. However, those prescribed burns would not add to the trend of increased burned areas. But out of fear of reducing national forest timber harvest, the national forest managers more slowly adopted prescribed burns. Sequoia, Stanislaus, Sierra, Inyo, and Plumas National Forests only began igniting prescribed burns during the last 2 decades, and that would indeed add to the observed trend of increased burnt areas. What's more difficult to measure is the 1970 switch from fire suppression to a let it burn policy. That also increased the burnt area relative to the mid-20th century. Now, calling their policy let it burn suggested to nearby communities that their fire managers were not doing their job, so it is now called Wildfire Resource Benefits, or WFRB. The policy is limited. Any unnaturally ignited fire was still required to be immediately put out. Similarly, WFRB policies could not let natural fires burn wherever human populations were threatened. The greenish colored areas are where the WFRB let it burn policies can be enacted, and those areas are unpopulated areas, mostly in the Sierra Nevada. Lastly, fire suppression initiated decades ago set the stage for larger and more intense fires today. Fire suppression allows ground fuels to accumulate, which more readily carries fires across the land. Additionally, fire suppression allows more ladder fuels, comprised of larger shrubs and younger trees, to accumulate. Ladder fuels carry fuels from the ground into the forest canopy, and canopy fires create more embers that are carried by the winds. Firefighters had great trouble containing the huge 2021 Dixie Fire because the burning embers would travel past their fire lines and start spot fires up to 4 miles away. So I advise everyone to ignore Gutierrez's and the media's alarmism. The average temperature they used was a bad statistic. More fires can be ignited even in cooler temperatures. We can reduce fires ignited by electrical ignitions. We can reduce burnt area extent with better fuel management. And we can only accept that natural El Niños, La Niñas, and the Pacific Decadal Oscillation all control the humidity extremes that lead to fires. But we can adapt, and natural wildfires can be beneficial when intelligently managed. Up next, maybe, an analysis of dubious climate change attributions of floods and droughts. And until then, as always, embrace renowned scientist Thomas Huxley's advice that skepticism is our highest of duties and blind faith the one unpardonable sin. And if you appreciate the science clearly presented here, science rarely presented by mainstream media, then please give it a like, share it, or copy the URL of the video and send it by email to friends. Subscribe to my channel for easily finding all my videos, or read my book, Landscapes and Cycles, An Environmentalist Journey to Climate Skepticism. Thank you.